Okay, if you clicked on this video, you probably thought the title was a bit silly because I'm saying that your next telescope should be a 3D printer instead, which makes no sense. But I want to explain to you where I'm coming from. And because I've found throughout the years that 3D printers are, for me, an essential tool for astrophotography. And they've recently come down in price while having incredible tech that make them completely idiot-proof. And that's why I want to start recommending something on this channel, like recommending general astrophotographers consider getting a 3D printer because it can be a lifesaver for our hobby. Now, I want to show you exactly what can be done with this printer with an example of fitting an electronic focuser on something that doesn't support fitting electronic focusers, thanks to the power of 3D printing. Before that, I want to quickly introduce what I have next to me. This is an Elegoo Century Carbon 2 3D printer. It is, as far as I know, the cheapest 3D printer you can get that has multicolor filaments. So the filament is like the plastic ingredients that makes it into the 3D printer. There's actually 4 spools attached to the 3D printer right now, and it can switch between the spools in different colors like automatically. At the same time, it has a screen to control everything of the printer, the settings, actually launch prints directly from here. It can support local network as well as cloud printing. So I actually access it from my computer over my local network and just send print commands just like I would for a normal paper printer. It's pretty insane. It supports all types of filament, even though I only recommend like PETG and PLA for astrophotography. I'll get to those details in a bit of more time. It's also a type of printer called a Core XY type of printer where the bed where things start to get printed, so that little thing here moves only up and down, and then you have a print head. Let me bring it forward. Here it is. We have a print head here that moves side to side and front and back to do the printing. And all of that is in an enclosed space so that you can more or less control the temperature within the 3D printer, which helps to have stable prints. So finally, there's a package like that that has everything you need for foolproof 3D prints for astrophotography and anything else, while at the same time being remarkably cheap. This is $420 US, nice, with 2 spools of filament, I think 1 kilogram each, which is cheaper than most smart telescopes, cheaper than a lot of our filters, cheaper than a lot of stuff, and yet this thing can be a lifesaver. Okay, without further ado, let me show you how much of a lifesaver it can be across multiple examples. Let's go. Okay, so why am I saying that a 3D printer should be your next telescope? Because it's not a telescope. What I mean by that, it is an insanely useful tool to have in the hobby of astrophotography. Honestly, it feels like a magic power because in astrophotography there's lots of very custom small scale stuff that needs to be built. There's like adapters all over the place. There's adapting your telescope to a focuser. There's mounting some weird PCs like the Milliquieter series onto your telescope. There's adapting stuff to finder shoes. There's some non-standard finder shoes like on the SQF55 telescope. There's having issues with your lock screw because it doesn't reach far enough into the telescope. Actually, I have this problem with the SQF55 and I solved it with this 3D printer. So yeah, there's a lot of stuff, and a lot of those things, either they're not made at all, or they're made and they're very expensive because they're not made at scale. Obviously, it's a small niche. Or maybe they're made, they're somewhat decent price, but they come from AliExpress, so they take forever to ship. In my case, there is no commercially available adapter to fit an EF to this SVBONY 535 lens that I've reviewed on the channel recently, which means that for focus, I have to do things manually, which is a pain in the butt. It also means that throughout the night, as the temperature changes, the focus point changes, and my stars will get more and more out of focus, which is a shame because otherwise this is the perfect tiny travel rig with a strain wave gear mount, with an ASI 2600 MC Air camera with an integrated control center. I just need to be able to fit an autofocuser there. That doesn't exist. So what am I to do? Fortunately, there are people who are much smarter than I am who reviewed this lens and immediately decided to make an adapter for the lens. One of those people, actually the only person who did that is fellow YouTuber Deep Skylab. I'll put the link down in the description. Excellent channel, by the way. And he made a 3D printed adapter, like we see here, for the SV535, which is perfect. In the description, there's a link to the STL download. STL is basically a file type that is a 3D model, and we can download the, I don't know why he put SVG, it's actually STL file here. So let's download it. Then once we've downloaded it, I can open the Elegoo Slicer, which is a piece of free software that comes on the printer manufacturer website. I'm going to click on Prepare, File, Import the STL. This is it. So now we have the STL file that is like in our printer, like say printing software that we call a slicer, and you'll understand why in a moment. And the first thing that we want to do is make sure we'll be able to print it properly. Right now you can see at the bottom is the print plate. And so if I look upwards, this is the direction of the z-axis, right? Which means that right now there are surfaces like this guy here that are horizontal, but they don't have anything under them to support them. And the 3D printer prints layer per layer, so that's going to be an issue. So we want to click on this little button here, which will orient the object in a way that makes it easy to print. And then it's very easy. I choose my material. So there's multiple filament types in 3D printing. The most common are PLA and PETG. PLA is a simple material. It works, but it's not very thermally stable. So it's good to print like batten-off masks that will stay inside, but not something that will stay under a cover or in a hot garage on the telescope. And then there's PETG, which is what I'm going to use here because it is more resistant than PLA, less brittle, it has more flexibility to it, and it is much more thermally stable. And that's what I would usually recommend for 3D printed accessories. Then I choose a profile, so I can go for strength or standard, and all that does is it sets parameters here at the bottom properly. I might as well go for strength while we're at it. And then we can click on the slice plate button, and that translates your 3D model into a list of layers that the printer can print. And that's why this is called a slicing software, because we take a 3D model and we automatically slice it into layers that the 3D printer can print. Now, I would suggest doing something when you have like this weird ring on the bottom. I would actually go to Others, Brim Type, and set it to no brim. This can be useful when you have very tiny things that you want to print that could lift off the plate, but that's not the case here. So I have no brim. Now we no longer have it, and it's going to be perfectly fine. And you can see that printing this will take us 55 minutes. So within 1 hour, I'll have an EF adapter for this lens that I'll be able to use, and that thing is not sold anywhere. So I'm going to go here, click on print, click again on print, and we're going to upload, and we can print immediately actually, but I just want to show you what it looks like on the printer page. So I'm going to say upload and switch to the printer page. So now that is uploading the model or the slicing instructions to the printer over network, and I'm on the page, and here it is, our Focus V2 535 that's going to be printed in PETG. I have multiple filaments there on the side of the printer, from PLA black and red to PETG black and red. I've already actually reused a lot of my old filament with this printer to print some other stuff that I'll show you in a moment. But here we go with PETG PLA, and I can start the print because here we go, we have everything, and I need to select which PETG I'm going to use, either black or red. I think red goes well with ZW stuff there, and also goes well with the mount actually. Touch of red, but then the EF will be red. I'm wondering, probably black. I'm going to go black, but you can see this is one of the advantages of this printer is you have multiple filaments or multiple materials that are available that you can get from different colors and just feed as you want. The printer is actually able to print multicolored stuff, which is kind of pretty cool, especially at the price point. But anyway, let's click on print. And what will happen is now the printer, this is a live view of the printer. There's an internal camera in there, and it's going to heat up its nozzle, which is there. That's going to be used for printing. Heat up the bed so this area here, and then just start printing while we can monitor it. And in 1 hour, I'll be able to fit an EF to this lens. Amazing stuff. So see you a bit later when I can show you the printing process, and at that time also what kind of stuff beyond this can be available online and printed. Let's have a look then. Okay, and while it's still printing there, you can see we have 14 minutes left and we can see in real time what the printer is doing. I want to tell you about other stuff that can do this. Not just like EF adapters, there's all sorts of stuff that are available online for you to actually print and use. So if you search for something called Thingiverse, there's another one called Printables, there's another one called MakerWorld, and each is kind of more or less attached with their specific brand of printer, but overall in the end it's just like 3D models. So you can print regardless of printer. This is like Bamboo Lab printer, for instance. Printables is Prusa printers. This guy is Instant Maker, something like that, I don't remember. And there's all sorts of stuff that are available, but also for astrophotography. So if there's also a search engine called Yegi.com, which actually has it's a meta search across all of those websites. And to give you an idea of what is possible, you can search simply for your telescope name or for your equipment name. So SQF55, ASCAR SQF55, immediately focused mount, button of mask, step down rings, another focus mod, find a scope adapter, tube rings and accessories for the SQF55, and SQF55 front stabilizer. So we can look at that. You can create this. So here it's the red part here that you'll be 3D printing. Then you buy cheap screws, pulley and timing belt from Amazon. And bam, you don't need to wait for the ASCAR official kit for autofocus. You can just make your own and have it available very quickly. There's a baton of mask for the SQ55 if you're not using autofocus. Very useful, easy to print. That's gonna print this guy is gonna print in 15 minutes. That guy is gonna print in half an hour to an hour. And this guy's step down rings, probably 15 minutes. And even this kind of system there with geared rings, that's absolutely printable in our 3D printer there, in the Elego. So all of those, you can have your own little adapter for the ASCAR. This time, you don't need a belt and pulley. You can just use geared stuff, which I kind of like. So it's that way you don't need to wait for Amazon as long as you have the screws available. Pretty cool stuff. A finder shoe adapter. I actually printed one in the past and use it for my SQF55. And then this collection of accessories like tube ring for the SQF55, all sorts of stuff that are available. Incredible things, as well as a front adapter. You can see just searching for something gives you so many things that can make your equipment and more resilient to failure, like this kind of front ring for the ASCAR SQF55 that helps avoid tilt. And you can search for all sorts of equipment. I could search for the Carbon Star, so my Newtonian telescope, for instance. Carbon Star, there you go, immediately. You get tons of stuff. You can get a back cover. Oh, that's a nice one. Oh, cool. I want those dew shields. I might actually print those. Those would take longer. But there you go. You have a dew shield for your Carbon Star 150. But other stuff as well. You can have baton of mask, tri-baton of mask. And those two are actually things that I designed. A mirror mask so that you can avoid the clips creating on the mirror from creating diffraction spikes. A back cover, and talking about back cover, depending on your specific model of the Carbon Star 150, this guy might be a little bit too small, and that's very easy to remedy. You can do a test print in PLA, for instance, with with settings that are very quick to print, and then see if it's the right size for your Carbon Star. And if it's slightly too small, for instance, you can select any object, go to the scale button there and say actually make it 102% scale, slightly bigger, right? So you can change the size of the objects that you're printing after downloading them online. And that's, I think, very useful. You can search for more stuff like SV241, the power box from SV Boni, and immediately you see finder shoes so that you can mount it easily. I printed one of those with the Elegoo printer using leftover filament that I had, and I made sure, so now it's orange color because I used my orange filament. Also, this little thing at the top is a Raspberry Pi 5 that runs Nina, and this case I printed with the Elegoo printer, and now I have like a super cool little control system that has a lot of parts that are 3D printed that I wouldn't have had otherwise. And all of those, they're printable within like 1 to 2 hours max, everything together. So it can really be a lifesaver when you need something to just like print it and have it available immediately almost. By the way, there are times when you can still get better stuff than the free models by shelling out of money. This is an example of a cable management clamp for the SV241. You'd find some for the ASI Air as well. So if I search for ASI Air, I'm sure stuff will, here you go, like cable management stuff. The initial design for these things actually came from a seller on Etsy called Smart Components, who's also a Patreon supporter of mine. And I've tested his model versus, which is not available, you have to buy the 3D printed parts, versus the free models available online. I gotta say, it's very different. This is far superior. So this is an area where maybe you don't want to print it yourself, you want to buy the thing 3D printed by the professional who 3D printed and designed exactly what you needed. So there's sometimes you want to just purchase the thing. Of course, I have the link to that page also down in the comments. And you can also search further afield, like Melee Quieter. Bam, Melee Quieter. Let's search, are there any things that have been built for the Melee Quieter series that we use in astrophotography? Of course, there have like lots of adapters for the Melee Quieter that are not really available for sale easily, and you get to get those mounting. That's a super cool mounting system for the, wow, huh. Well, okay, I kind of want to print it, but you can see all of the kind of stuff that is available to print, and really the only limit is the models available online and imagination. And when I say imagination, there's a reason for that. Because if you go to a website called tinkercad.com, and again, I have all of the links down in the description, you can actually create your own designs. And it's all free. You just create a free account, and then you have access to this whole software there. And you can see here I designed something a bit weird. A tiny little cylinder there that has 4 millimeters diameter, and the height is actually 2 millimeters. I probably could have gone with 3 millimeters of height. And why did I do that? First, how do I do that? I just add a cylinder to the page, and then I change the dimensions. Very easy to design. But what is this? And how is this helpful? Let me show you. I had an issue with the rotator of the SQF55 telescope that I have. By the way, this little orange 3D printed adapter, that's what we saw just earlier in the video. But going back to this little hole there, which is for the locking knob of the SQF55, I had a problem with that knob that even if I put it all the way in, basically I ran out of thread, and you can see I'm fully threaded, but the rotator is completely unlocked still. And that's because on this screw, I run out of threads. The threads are too short, or they became too short. I don't know what happened because it used to work fine in the past. But basically, I run out of threads before the screw head can contact the bottom part here within the hole. So how am I to fix that? That's where that little tiny cylinder that I printed with the Elegoo printer comes into play. Basically, I made it of such a size that it fits in the hole, but it's high enough that it's not going to get lost within the rotating system here. So I just put it in. Now I have it in the hole, and now if I put in my locking screw, it actually locks. I can no longer rotate the rotator. It has, now this is the screw from the camera, right? So that's fine. The rotator itself doesn't move anymore, and that's thanks to this little item that I put in there that I just 3D printed. It took me 5 minutes, and now it's fixed. Of course, I could just have bought some M5 bolt with fine pitch thread, so 0.5 millimeters pitch, I believe, which would have worked. But the thing is, at least here in Japan, my local hardware store doesn't have that. Amazon doesn't have that. If I wanted to get it, I needed to wait around 2 weeks for a shipment from China. So I didn't want to wait 2 weeks. Instead, I spent like 5 minutes designing that tiny little cylinder and slid it in. I didn't really have any other items that I could use as is, but the printer just like made everything possible. So that's what I mean when I say that it's almost like you have a magic power. Talking about magic, it seems that a few minutes ago, the EF adapter for my SV535 lens is done. Let me get it and show you how it looks. And here it is, something created out of nothing within like a bit over an hour. And it's there. We have the adapter for the EF that should fit on this lens. Let's put it together. First, I put the EF onto it. I've already gotten from Amazon a pulley with timing belts, and I just use the long, I think M4 screws. And there we go. We have the EF mounted. I make sure to keep the screws kind of loose for now because I'll be able to adjust the belt tension like that. And now I can mount it on there. And before I mount it on the lens, I do have the timing belt. This one is 235 millimeters long, so I actually had to cut it myself. But I just slide it in so that I have it available. Now on the other side, I can use M3 screws here, and the holes there are not tapped. So a lot of people use taps. I can just like force the screws in and it actually just works. So there's no big problem there. There we go, just screwing the screw in. And on the other side, I'll be fitting a tiny little bolt. And once I'm more or less ready, I can slide everything in and it will fit exactly on this silver ring there. And now that I have the thing mounted and secured on the lens, all I need to do is set the belt tension to the maximum I can do, and then tighten the bolts here. Then I can put back the dew shield. And then all I need to do is plug in the USB. And bam, here we go. I have now a fully automated portable rig, including the autofocus. All thanks to a 3D printer and of course Deep Sky Lab that made the model available. Okay, so with that, let me also give you some idea about why I'm showing off this particular printer. The truth is, I was planning on buying it. I was looking at the Elegoo Century Carbon 2 or the much more expensive Bamboo Lab P2S. And this was to replace my existing 3D printer, which is this guy here. This is the Prusa MK3S Plus 3D printer. It was extremely expensive, over $1,000 if I remember correctly when I bought it, and it has a great reputation. It's like most people look at it as a workhorse that always works, never fails, always is awesome. My issue is that with this printer, sure, I was able to make use of it, but I never was able to print correctly with it. Probably user error. I have no idea. I followed so many tutorials and yet I always got stringing. I always got like printing issues. I don't know what I did wrong, but this was definitely a printer that was not foolproof at all. I'm sure so many people swear by it, but yeah, it didn't work out for me. And I think one of the reasons is that it's not enclosed. It's a bed slinger type of printer, meaning the bed is moving back and forth. And also, very annoyingly, it cannot print by default over network. I have to move things via an SD card whenever I want to print stuff. So it looks very rudimentary compared to like the UFO that I have next to me. And so while looking at potential printers, as I mentioned, I ended up looking at this and looking at the Bamboo Lab P2S, but the Bamboo Lab P2S is twice the price. And at least with the module that lets you have multiple spools of filament. And that's not something that I could really justify. So I almost bought the Elegoo, but I decided like, hey, let's reach out to Elegoo. And I reached out and they answered immediately and they're like, oh yeah, let us send you the printer for free. So yeah, I'm getting this printer for free. So this could taint my opinion. That said, this is not a sponsored video as I'm not getting any further monetary compensation for this. And also I cannot really review the printer per se because I am not a 3D printer expert. I recommend looking on YouTube for various reviews. Most of them say like it's a very good printer, but it lacks some features compared to the more expensive Bamboo Lab P2S, which, yeah, I would agree. I mean, probably I don't have the P2S to compare, but yeah, that makes sense. But I've got to say, I've printed a lot of stuff with this thing. I've printed, of course, Astro stuff from, a butt plug for my CS150. I've printed what I showed you earlier for the EAF. I've printed so many things with this in rapid succession, and it just worked out of the box like perfect prints. And with whether I'm using PLA, this guy here, or the one in the back, which are PETG, and it just worked. And so that's why finally I think there is something that is foolproof, meaning me-proof, that I can recommend for astrophotographers in general that has a low price of 420 US dollars. It doesn't mean that everything is super easy. You still need sometimes to make sure that your filament, when you're not using it actively, you want to keep it in an airtight box with tons of desiccant inside, because filament loves humidity, and when, especially PETG, and when humidity gets into your filament, bad things happen. I mean, your print qualities will be bad. So it's not all sunshine and rainbows when it comes to 3D printed, but really it's an evolutionary leap compared to my old Prusa, and that's where I'm coming from. A couple of negative things about this printer is, you see all of those things. This is a printer poop. That's what it poops out when it switches filament from one color to another, and it poops out a lot. So there's some filament waste that comes in. Also, I will say this is both a good point and a bad point. The printer has a completely offline mode, meaning it doesn't rely on cloud, and it means what you print is none of anyone's business, right? Whereas something like Bamboo Lab, I think mandatory, everything goes through the cloud, so Bamboo knows exactly what you print, and it's a Chinese company. So things to think about. So this guy, I'm using it in local only. I got to say though, when I was trying to use the cloud features, the cloud servers, I don't know, they were often down, and that caused me issues. I couldn't connect to it, so I went with just local network. Most people don't have issues. Maybe it was a timing issue for me, but it's something to keep in mind. The multicolor printing on this, by the way, works great. And I've been printing a lot of non-astrophotography stuff as well. Things like my computer display stand with, I used my leftover filament from my Prusa printer to print a full stand with storage for my monitor. Actually made my desk much cleaner. I printed some smartphone stands that are foldable so I can use them when I'm on the go and I want to watch something on my smartphone. I printed very loud, very tiny whistles for both me and my wife in case of an emergency. And really there's an insane amount of stuff that you can print that is just generally useful and sometimes very impressive. Like if you just search for print in place type of deal, you have like mechanical stuff that you don't need to assemble. It's just pre-assembled when you print it, and it's just mind-boggling. You also have, by the way, Bahtinov mask generators where you can input your parameters for a Bahtinov mask and just generate the 3D model for you to print like that. Same for screws. I was able to print like M5 screws without issues, but it's still pretty impressive that this is available. Even the microphone stand that I have on my camera there that holds my microphone receiver. I broke the one that came with the microphone, so I 3D printed a replacement, and it works great. So that's where I'm coming from. Of course, drawbacks is it's a hobby. And so as a hobby, you might go the deep end and buy a lot of stuff, but this helps not do that because this just works out of the box. And the only thing you really need to care about is to keep your filament dry. So don't do what I have right now, which is having it hanging around all the time here. You want to generally keep it in the box with desiccant until you're ready to print. But otherwise, this is, honestly, I've been printing so much with it. By the way, this is a print that comes on the printer by default. It's a scraper to remove your 3D prints after you're done. And it's just there available as a model on the printer to print immediately. But yeah, anything is really possible, and that's where I'm coming from for astrophotography and for the rest. Let me know your thoughts down in the comments. Would you want to try out 3D printing for yourself for astrophotography, or in general? Is something like that something that could make it possible for you for around $400 something? Or is it just like too big, too large, it's actually not super noisy. I think this is something that we should consider for the hobby, and that's where I'm coming from when I'm saying like maybe your next telescope should be a 3D printer. Let me know what you think down in the comments. Leave a like if you enjoyed the video, a dislike if you thought this is stupid and you just are going to buy a new telescope and not a 3D printer. And if you want to have the channel out and you're planning on buying anything from Gina, High Point Scientific, even Amazon, if you do so after clicking one of the links that I have down in the description, it will help me out at no cost to you. I'll have links to the printer, to everything else I mentioned as well. And of course, if you want to sponsor the channel directly, become a VIP member and help make all of those videos possible, you can join the channel as a member. It's the join button next to the subscribe button, or you can become a Patreon member on my Patreon site. The link is down in the description. You guys, you know it, you make all of this possible. So thank you so much for your support. With that, I hope this was interesting. Thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.